All right, to find or to solve part C, to find the position, velocity, and acceleration at t equal to 0.25 seconds. The first thing you're going to do when you do this question is you are going to change your calculator mode to radians. All right? To find the position, x equals 7 centimeters times the cosine of omega, which is 3 pi over 2. 3 pi over 2 times 0.25. Again, what is this? This is the equation x equals a cosine omega t, right? That's the equation. Put this into your calculator, which I have not yet done. That's going to be 7 times the cosine of 3 over 2 times pi times 0.25, close my parentheses, and I get 2.68 centimeters. And it's positive. It's a positive answer. So, and that matters, 2.68 centimeters, which I'm assuming that to the right is positive and to the left of equilibrium is negative. So this thing is 2.68 centimeters to the right of equilibrium at 0.25 seconds after release. Okay? I don't know which direction it's going, because it could be going to the right and further to the right. It could already have gone all the way over and been on its way back. All right? All I know is here's equilibrium, x equal to 0, and this thing's oscillating back and forth this way, okay, between those two sides. And all I know is that this is 7 centimeters, this is negative 7 centimeters, and at the moment, it's at 2.68 centimeters, which is, I don't know, over here somewhere, all right, from equilibrium. Again, if I got a negative answer, it means it would be over here, but I didn't get a negative answer. So the next thing I'm going to do is find its velocity. If the velocity is positive, it means it's still going to the right. If the velocity is negative, it means it's going that direction. How am I going to find the velocity? Well, I'm going to change colors because I can. And the velocity is going to be equal to negative omega times a, and we keep the negative sign in here, times the sine of omega t, which is negative 3 pi over 2 times a. I'm just going to leave it as 7. I'm going to stay in centimeters for the heck of it. And that's going to be times the sine of 3 pi all over 2 times 0.25. Okay, that's probably not the best color. Right? I'll change colors here after this. So let's figure this out. So negative 1.5 or 3 over 2 pi times 7 centimeters times the sine of 1.5 pi times 0.25, close parentheses, and I get negative 30.5 centimeters per second. Again, I'll change colors. Negative 30, what did I say? Negative 30.5 centimeters per second. The negative sign means that it's right here going to the left. All right, going back that direction, negative. And then the last thing is to find the acceleration. So acceleration equals negative omega squared times a times the cosine of omega t. So this is negative, parentheses here, 3 pi all over 2 squared times 7 centimeters again times the cosine of 3 pi over 2 times 0.25. Again, I'm in radian mode. I could really mess you up. You have to pay attention to that. So here we go. Negative, open parentheses here, I've got 3 over 2 pi, close my parentheses and square it, times my 7 centimeter amplitude, times the cosine of 3 over 2 pi again times 0.25 seconds. And that comes out to be negative 59.5 centimeters per second squared. Negative 59.5 centimeters per second squared. Okay. I just left it all in centimeters because I can. You don't have to, but just because that was in centimeters. Where did the 0.25 come from? Remember, that's the time. I'm looking for where is this thing. I'm trying to describe its position, velocity, acceleration at this moment after release. And so I put in 0.25 wherever I see a t. 0.25 seconds, 0.25 seconds, 0.25 seconds. And so it's 2.68 centimeters, positive 2.68 centimeters, so it's to the right. It should not surprise you that because it's to the right, it has a negative acceleration, because its acceleration is always going to be opposite the displacement, because the force has the opposite sign from the acceleration. Remember, that's characteristic of simple harmonic motion. Force and position have opposite signs. And when this thing got over to the other side, it would have a negative position and a positive acceleration, because it would also have a positive force. By the way, how could you find the force of the spring at any given moment? You need to know the mass of the object and multiply it by the acceleration. You have to be in meters per second squared. That's how you find the force, F equals ma. All right, that's the end of example 1. Yay.